Good day. This video clip is for the demonstration of dealing with coordinate systems. Projection and coordinate systems are a complicated topic in GIS, but they form the basis for how a GIS can store, analyze, and display spatial or spatial data. Understanding projections and coordinate system is an important knowledge to have, especially if you will deal with many different sets of data that comes from different sources. In order to quickly understand and apply the concept of coordinate system and map projections, we will categorize the map coordinates using two types: the geographic coordinate system, or the GCS, and the projected coordinate system, or PCS. The difference between the two is that the GCS is an angular unit with parameters of latitude and longitude, and it must be noted that the GCS is unprojected. On the other hand, the PCS is a metric unit with northing and easting as its parameter, or the x and y coordinate, and it must be noted that the PCS is already projected. Example. Example of GCS is the EPSG 4326 or the WGS 84 or the World Geodetic System of 1984. Example of PCS is EPSG 32651 or the UTM Zone 51N slash WGS 84. The EPSG 32651 make use of the Universal Transverse Mercator or the UTM as the projection, with the WGS 84 or the World Geodetic System of 1984 as its base reference coordinate or the reference datum. You may also access all other EPSG codes using the spatialreference.org. You may visit the site by just clicking spatial reference, then list all references. And then let's take a look for the Philippines. So in the Philippines, we are making use of this set of EPSG. So from EPSG 3121 up until EPSG 3125, it makes use of the Philippine Reference System of 1992 with zones 1 to 5. And using the older reference datum, we are using EPSG 25391 up until 25395 for the reference datum Luzon 1911, zones 1 to 5. So using your QGIS, you may also access those EPSG. So let's type here Philippines. Okay, so again, for the projected coordinate system, we are using the Philippine Transverse Mercator for the projection, and for the reference datum, we are using the Luzon 1911. This is zone 1, zone 2, zone 3, zone 4, and zone 5. Another reference datum is the PRS 1992. PRS 92, or the Philippine Reference System of 1992. We have also 5 zones: zone 1, zone 2, zone 3, zone 4, and zone 5. For the Universal Transverse Mercator, we are making use of WGS 84. Okay, so here, WGS 84, we are making use of the Universal Transverse Mercator, specifically the Zone 50, 1N zone. Okay, this is the zone 51 end zone. And we are also using the zone 50 end zone for Palawan and zone 52 end zone for the easternmost part of the Caraga and Davao region. Now, let's create a new folder, a new project, and save it. So let's have dealing with coordinate system. Let's name this as reprojection of layers. Okay, so with this, we will load two vector layers. Control Shift V. We will first load the base map. So kindly proceed with your LabX3 dataset, part 3, vector, filter it to S3 shapefile, Philippine Admin 2009, open, add, close. This is our base map or the reference base map. So double click and you will see that the coordinate reference system is EPSG 32651 WGS84 UTM Zone 51N, meaning it makes use of the UTM or the Universal Transverse Mercator as its projection, while the reference datum is the World Geodetic System of 1984. Next, let's load another shapefile. Then let's transfer to the vector hazard map folder. Let's download or import the first file, which is the SDN rain induced landslide. Open, add. Now, as you can see, the source CRS of the file is EPSG 25395 Luzon 1911 Philippine Zone 5. And it must be noted that our base map is 32651 WGS 84 UTM Zone 51N. As for now, we will not transform this yet. So cancel muna natin. Then close. Double click the SDN rain induced landslide. Cancel. Its coordinate reference system or CRS is Luzon 1911 Philippine Zone 5. It makes use of the Philippine Transverse Mercator as its projection and Luzon 1911 for the reference datum. Let's load another file using raster. Another file which is a raster image. So Control Shift R. Control Shift R is intended for raster. Then let's go to the raster folder. Let's import or load SRTM 4190M Philippines. Open, add, close. If you will check at the projection is EPSG 4326 WGS84, and it must be noted that there is no projection here. So this file is a GCS or Geographic Coordinate System using with WGS84 as its reference datum. No projection was included here. Okay, now as the vector admin layer will be the reference base map, which is the field admin 2009. Its coordinate system is EPSG 32651 WGS84 UTM Zone 51N. And this will be the coordinate system of all our dataset, meaning that every dataset, whether it be a vector or a raster, okay, that are different from the coordinate system will be reprojected to this coordinate system. Failure to do so can make analysis and mapping to have unexpected or incorrect result. Okay, now if you will look at this. This is the Phil Admin 2009, our base map, and this is the SDN file. It seems that they agree with its projection, and as well as with the SRTM. It seems that it agrees with the projection of our base map. However, this is simply because of the on-the-fly projection or the fly-to projection setting of the QGIS. In the older version of the QGIS, the on-the-fly projection button must be enabled first before reprojecting. However, with the current versions, all versions on the third series, QGIS 3.XX onwards, has already automatic reprojection of the on-the-fly projection. Okay, however, it must be noted, just as mentioned a while ago, all the files should be reprojected, meaning once you double-click the file, the CRS must be reflected with the same CRS with the base map. Okay, so in order to reproject it, okay, we will start first with the vector layer. So reprojecting vector layer. So click the vector layer, then vector, data management tools, reproject layer. So select the input layer, which is the SDN rain induced landslide. The target CRS is EPSG 32651 WGS 84 UTM zone 51N. Let's reproject it, save to file, deal with coordinate system. We will save the geo package there. So we will have this reproject, we will have this as SDN underscore rain underscore induced underscore landslide underscore EPSG 32651. Save. Then reproject. Close. So as you can see, a new layer was created. If we double click this, you can now see that the coordinate reference system is now EPSG 32651 WGS84 UTM zone 51N with a universal transverse Mercator as its projection and Luzon and World Geodetic System of 1984 as its reference datum. Next, let's reproject the raster layer. So let's click the raster, which is the SRTM 41 underscore 90M Philippines. So let's click raster, then projections, then warp projection or the reprojection. So our input layer is SRTM 41 underscore 90M Philippines with an EPSG of 4326. So its source CRS is 4326 and its our target CRS is EPSG 32651 WGS 84 UTM zone 51N. Let's reproject. So save to file. So as you can see, it is in TIF file. So SRTM 41 underscore 90M underscore Philippines underscore EPSG 32651. Save. Run. So there's an error. So instead of directly saving it, so let's close it again. Then let's reproject it again. So raster, projection, warp. So let's have, again, our default is 4326 and our target is 32651. without changing the file name. So let's run this. Close. So this is our reprojected file. Okay, as you can see, there's a symbol here. This is intended for temporary layer, meaning this file is temporary. So we have to save this. Okay, so export, save as. Let's change. Okay, so SRTM41 underscore 90M underscore Philippines underscore EPSG for 32651. Save. Then let's have its layer name. Okay. Now it is already saved as SRTM41 underscore 90M underscore Philippines underscore EPSG 32651. Double click. You can now see in the coordinate reference system, it is now EPSG 32651, WGS 84, UTM zone 51N. Okay, let's click the projected since this is a temporary file only. Remove. Okay, then save. Let's close this file and let's load our previous file that we created last time, the georeferencing scanned images with available GCPs. Let's cancel this. Cancel. So previously in our previous module, we had the georeferencing of this scan file. So again, this one has an EPSG of 4253 to zone 1911. So this is basically a GCS, no projection. And our Philippine admin 2009, cancel. It's WGS 84, UTM zone 51N, EPSG 32651. Okay. Now let's change the EPSG here with our usual UTM zone 51N, which is EPSG 32651N. Apply, then okay. Now we have set the project to 32651N. Now what we will do is to reproject the Abra de Ilog. Okay, take note the Abra de Ilog is EPSG 4253. So we will save its raster. But before that, let's save this project with another file. Save as. So instead of georeferencing scan images with available GCPs, we will transfer it to dealing with coordinate system. So reprojection of Abra de Ilog. Okay. Then let's have the raster. Then reproject. or warp projection. So originally our EPSG is 4253. This on 1911. We will make it to EPSG 32651. Zone and run. Close. We will save the file to its folder. So abra the elog underscore EPSG 32651. Save. Okay. So if we will click this information, it is already EPSG 32651 WGS 84 UTM zone 51N. Okay, then let's delete the reprojected temporary file. Okay, that's it for this video clip. Thank you.